Hello viewers, this is teacher Red Duncan from Namugongo Secondary and Vocational School. We are going to have our math lesson. The topic is trigonometry. We are going to look at trigonometry. Trigonometry, next. Trigonometry is a special branch of mathematics that deals with the relationships between the length and angles of triangles. We are going to basically be looking at angles and the sides, the length of the sides of triangles of any shape. Under this topic, we are going to look at cosine, we shall look at tangents, we shall look at sines, and what each of those three terms stands for. But before we go into details, we need to know what are some of the applications of trigonometry in our daily lives. We need to know. I'm going to mention a few. I'm going to give you 5 applications. Then you, your side, you also look for others, and then you give me feedback. That is one of the assignments you're going to do. Now, it is used in video games and music. Sounding in ears when they are recording music, that music is compressed into sound waves, and that is application of trigonometry. The second application of trigonometry is in constructions. The structures you see, the houses we live in, those architects use trigonometry to measure the slopes, the height of your roof. That is all trigonometry. The third application of trigonometry is in flight engineering. Flight engineers use trigonometry to find the height of planes and then the way they navigate their planes against air resistance. That is trigonometry. It's an application of trigonometry. The fourth is trigonometry is used in physics. In classical mechanics, we use trigonometry in resolving forces. You might have a force, and then this force is inclined at an angle, maybe theta, the horizontal, maybe force, let me say F. This force is going to be resolved into 2 perpendicular components, the vertical component and the horizontal component. So this is under trigonometry. This horizontal component and the vertical component, we get them by applying trigonometry. We resolve the given force into 2 perpendicular components. That is one of the applications in trigonometry. And then the last application. But this does not mean that what I'm giving you is all. I've just chosen a few. You also look for others. The last one is in crime scene investigations. If a crime has been committed somewhere, crime investigators will come. You see them moving 2-3 steps. Then they do some measurements, 1 or 2 steps backwards, forwards. They go on moving and collecting information. In that process, they are using trigonometry because it involves length and angles. That is the first segment, applications of trigonometry in our daily lives. Now, after knowing the applications of trigonometry, then let's look at these special triangles. Because we said trigonometry deals with triangles, angles and sides of triangles. Now, let's look at the first special triangle. And this is what we call a right-angled triangle. Let me sketch for you one. So we've been doing from primary, so it's not something new. This is A, this is B, This is C. Is right angled at B. A right angled triangle is a triangle where one of its angles is 90 degrees. So if you have a triangle and one of the angles is 90 degrees, then that triangle is called a right angled triangle. Now I have my right angled triangle here, ABC, and angle A is acute. Angle A is acute. Acute angles are angles that lie between 0 and 90 degrees. Later on, we are going to see two more angles. We have what we call obtuse angles. Angles which lie between 90 and 180 degrees. They are called obtuse angles. Then we shall have the last part. They are called reflex angles. These are angles that lie between 180 to 360 degrees. They are called reflex angles. So let's first take our concentration to this special triangle. It's right angled and angle A is acute. We have where the arrow faces, that side is what we call the opposite. And then where the triangle sits, this one here is our adjacent. And we shall denote it with letter A, capital A. So we are going to use letter O. This one here, the longest side, we shall call it the hypotenuse. And we shall denote it with letter H. We shall denote it by or with letter H. The longest side SC is what we call the hypotenuse. The longest side S is called the hypotenuse. The side opposite the angle, that is side BC, is called the opposite. And the side adjacent to the angle, that is AB, is called the adjacent. Now, we are going to look at important ratios. Because in my introduction, I told you that trigonometry deals with the relationships of angles and triangles. And then I introduced to you the ratios of sine, cosine, and tangents. But I didn't tell you what each stands for. Now, time has come for me to explain those three terms. The first one is sine. Sine. I'm now interested in sine of angle A. And we take the first three letters. So I'll write it as sine of A. This is the ratio of the opposite, to the hypotenuse. So sine A is equal to the opposite out of the hypotenuse. Our opposite is BC. Our hypotenuse is AC. That is sine of angle A. The second one is called cosine. We write it like that, cosine. But we abbreviate it and take the first three letters and we say cos of angle A. This is equals to the adjacent, the ratio of the adjacent to the hypotenuse. This is equals to AB out of AC. The ratio of the adjacent to the hypotenuse is called the cosine. And then the last one is tangent. Tangent. This one we abbreviate it as tan. Again, you take the first three letters. This is the ratio of the opposite, to the adjacent. That is tangent, which is our opposite is BC, our adjacent is AB. That is tan. Those are the three ratios. Now, there is a shortcut for us to remember these three ratios. And we are going to look at so, car, repeat. So, ka, toa. S stands for sine. O stands for opposite. And H stands for the hypotenuse. Then we go to ka, the middle part, ka. C stands for cosine. A stands for adjacent. H stands for hypotenuse. And the last bit of it is toa, where T stands for tan, O stands for opposite, and A stands for the adjacent. Let's have the three. We shall say sine of A is equals to O out of H. Cosine of A is equals to A out of H. Tan of A is equals to O out of A. So you can easily get these ratios by remembering SOCA forward. Next. We are going to have examples. We are going to have our examples. I've prepared for you a number of examples. And the first one is again on the right angled triangle. Let me first clean this board. We have a right angled triangle ABC, a right angled triangle, the right angled triangle ABC has its adjacent as 4 centimeters and its opposite as 3 centimeters. Find Roman 1, the hypotenuse. Roman 2, tan A, sin A, and then cos A. So the triangle is given. This is our rectangle triangle where we are going to pick the information given in the question. The whole of it is the question. This is A, this is B, and this is C. It is right angled at B. This is our right angle triangle. It has its adjacent as 4 centimeters. This is my adjacent, 4 centimeters. The opposite is this one here, because this is angle A. The opposite is 3 centimeters. Now, our first question is, they want us to find the hypotenuse. Now, in order for us to find the hypotenuse, we are going to use Pythagoras theory, which states that the sum of the square of the adjacent plus the opposite is equals to the square of the hypotenuse. So when you square the adjacent plus the square of the opposite, that sum, the sum of the squares of the opposite and the adjacent, equals to the hypotenuse squared. Let's feed in. What is our adjacent? It is 4. So 4 squared plus the opposite is 3 squared. This is equals to SC squared. Now when you work out this, we shall get our SC as 5 centimeters. Our SC as 5 centimeters. So we go. That is the hypotenuse. Then Roman 2. He wants me to find a ratio of tan A, sin A, and cos A. I'm going to first write here. So, ka To get tan of A, you use the last one, TOA. You say tan A is equals to opposite out of adjacent. Now, here we got 5 centimeters. Now, my opposite is 3, my adjacent is 4. Now, viewers, the ratios of tan, cosine, and the sine have no units. Why? Because they are ratios of similar quantities. Even if I put here centimeters and centimeters, the centimeters will cancel out. You stay with 3 out of 4. That is tan A. The second one is sine A. You use the first one of so. You say that sine A is the opposite out of the hypotenuse. Our opposite is 3. Our hypotenuse is 5. And then the last one, part 4. Part 4 is the cosine of A. We shall use the middle one, which is k, which is adjacent out of hypotenuse. Our adjacent is 4 centimeters. Our hypotenuse is 5 centimeters, which is 4 out of 5. This is a very, very good example which teaches us how to find these ratios for right angled triangles. And we are using SOHCAHTOA. We are able to get the ratios without getting the angles. There's no need for us to get the angles. So we've used SOHCAHTOA. Next. I have a second example here, ladies and gentlemen. This one I'm going to explain more concepts. There are more concepts that are embedded in there. The second example is given that tan A is equal to 5 out of 12 and A is acute. And A is acute. Find without tables or calculators the ratio of sine A and cos A. Find the values of cos A and sine what? Sine A. Now, ladies and gentlemen, before we answer this question, I'm going to introduce to you to another important concept, that is quadrants. We are going to first look at a circle divided into 4 portions. The first one, 0 to 90. This one we shall call it the first quadrant. The second one is from 90 to 180. This one is called the second quadrant. Then from 180 to 270, this one we shall call it the third quadrant. And then from 270 to 360, we shall call this the fourth quadrant. There are 4 quadrants. Now, the first quadrant, that is from 0 to 90, all the angles here are acute angles. Angles that lie between 0 and 90 are called acute angles. Then angles in the second quadrant here, these are obtuse angles. These are obtuse angles. Then angles in these last 2 quadrants, we call them reflex angles. We call them reflex angles. Now, once you know those 2 concepts, then you go to the third concept. In the first quadrant, all ratios are positive. When I say all ratios are positive, you write letter A to stand for all. All ratios in the first quadrant are positive. What I'm meaning here is sine of any angle that is in the first quadrant is positive. Cosine of any angle between 0 and 90 is positive. And the tangent of any angle between 0 and 90 is positive. That's what I mean by saying that all ratios are positive. And we go with letter A. That's what we use. Now, in the second quadrant, signs are positive. Signs are positive. If you look for the sine of the angle between 90 and 180, that sign is going to be positive. The cosine will be negative. The tangent will be negative. So we take what is only positive. When we go to the third quadrant, tangents are positive. I'm going anti-clockwise. In the third quadrant, tangents are positive. The rest, negative. In the fourth quadrant, cosines are positive. The rest, negative. Now, you can see that I've written A, S, T, C. A stands for all. S stands for sine. T stands for tan or tangent. And then C stands for cosine. But whatever letter you see there stands for a positive ratio. Stands for a positive ratio. Now, how do you remember this? There are other simpler ways of remembering this. So we say all students take coffee. You move anti-clockwise, you say all students take coffee. You'll be able to write A, S, T, C. All students take coffee. Now, once you know this info, it is this information that is going to help us handle our next examples. Let's now go to the example in the question. My question is, given that tan A is 5 out of 12, and A is acute. Without tables or calculators, find a value of sine A and cos A. We come and draw a right-angled triangle. And we put here angle A, which is acute. Acute angles are angles that lie in the first quadrant. Acute angles are angles lying between 0 and 90 degrees. And all the ratios we are going to get, those ratios are going to be positive. So, this is my arrow. The side that does not form the angle is what we call the opposite. So this is angle A. I'm interested in this. This one is the opposite. We have our adjacent and we have the longest side, which is the hypotenuse. Now you go to the question and you say tan A is 5 out of 12. But you remember my previous submission, I gave you TOA. We said TOA stands for tan of A is opposite divided by the adjacent. That is TOA. Meaning that the numerator is our opposite. The denominator is our adjacent. So you come, our opposite is 5, our adjacent is 12. You see? We are basing our concepts on so, ka, TOA. I'm able to tell that if the ratio given is 5 out of 12, the numerator is the opposite. Then the denominator is the adjacent. Now, our task is to look for the hypotenuse. How do we do that? We go through Pythagoras theory. So we say the sum of the squares of the adjacent and the opposite will give us the hypotenuse. So we have hypotenuse squared is equals to opposite squared plus adjacent squared. So hypotenuse squared is equals to my opposite is 5 plus 12 squared. This is going to give me 169, which is my hypotenuse squared. You get your hypotenuse as 13. The hypotenuse is always positive. You know, when you take the square root here, square root, you get the result as positive or negative. But if you're looking for the hypotenuse is always positive. So my hypotenuse is 13. You come and write 13 there. Besides, we are looking at angle A, which is acute. Acute angles are angles in the first quadrant whose ratios are all positive. So we go. Once we have the hypotenuse, we can now answer his question. Let us get sine A. We are going to use so. Sine A is opposite divided by the hypotenuse, which is 5 out of 13. And that is the answer. We've been able to work out sine A. Then the second one was cos A. This is Roman 1. Roman 2, we want cosine of A. Again, we go to our saw, car, tower. I'm going to use canal. So this is going to be adjacent out of the hypotenuse, which is, my adjacent is 12, and my hypotenuse is 13. So 12 out of 13 is the ratio for cosine of A. 5 out of 13 is for cosine of what? Of A. All these ratios have no units. That's why you see I'm leaving them as 12 out of 13, 5 out of 13. That is my second example. Let me do for you one more example, and then I'll also give you an exercise to try. I'm going to do for you one more example, and then give you an exercise. Okay, my last example is if sine B is negative 12 out of 13 and B is obtuse find cos B. Find cos B and tan B. Yes, you are given this second number. Today, the ratio is negative. Sign is negative. That is why you have to be very, very careful. Let me remind you, before I handle this, I want to remind you of where I'm going to draw my triangle. In the first quadrant, we said all are positive. In the second quadrant, we said signs are positive. In the third quadrant, we said tangents are positive. and here cosines are positive. Now, when you look at the given question, already some quadrants are going to be discarded because the ratio is negative. We cannot have negative signs in the first quadrant because in the first quadrant all the ratios are positive. So a negative cannot be there. That one you ignore. You come to the second. In the second, we said signs are positive, but the question is giving us a negative sign. That means we cannot work there as well. So the first two quadrants are discarded because of the sign, because of the negative sign. The negative sign discards the two quadrants. The first quadrant is discarded. The same applies to the second quadrant. Why? Because in these two quadrants, signs are positive. Signs are positive in the first quadrant. Signs are also positive in the second quadrant. That means our angles or our angle will lie in the third quadrant and the fourth quadrant. Angle B lies in those two quadrants. It is in the third quadrant, it is as well in the fourth quadrant. We are going to work out each quadrant and we see. Angle B here is reflex. We are going to work out each triangle and we see. It cannot lie in the first quadrant, neither can it lie in the second quadrant, because as I've said, in the first two quadrants, signs are positive. We go. Let's first work out in the third quadrant. I want you to see how I'm going to sketch it. In the third quadrant, you come and draw from the origin, draw a right angle triangle. The 90 is always on the x-axis. That's where you put your 90. You can put the angles. This is 180. This is 270. This is the angle of interest. And remember, this is 0, and we are measuring anti-clockwise. 0 going anti-clockwise. The whole of this is angle B. We are looking at an angle that lies between 180 degrees and 270 degrees. The whole of that is angle B. Now, you come and put your arrow because you want to identify the opposite. This side where the arrow faces is the opposite. Now, you come to the ratio. You say sine B is negative 12 out of 13. You remember, so katoa. So you say sine B is opposite out of the hypotenuse. Meaning that the numerator is your opposite. The denominator is your hypotenuse. And I said earlier, the hypotenuse is always positive. So you put here your positive 13, you come and put your negative 12. Now, our task is to look for the adjacent. Because we have the opposite, we now need this side here, which is the adjacent. And how do we do it? Pythagoras theory. We shall say that opposite squared plus adjacent squared is equal to hypotenuse squared. When you sum these two sides that form 90 degrees, the result is equated to the longest side. So the sum of the squares of the two sides that form 90 degrees should be equated to the square of the longest side. So my opposite is negative 12 squared. My adjacent is what I'm looking for. My hypotenuse, 13. Now, when you square a negative, you get a positive. That's the adjacent, which is 169. we get our adjacent squared as 25. When a positive crosses the equal signs, becomes a negative. So I'll get my adjacent as plus or minus 5. Now, a while ago, in my previous example, when I was looking for the hypotenuse, I did put plus or minus. Why? Because the hypotenuse is always positive. But now when you are looking for the adjacent or the opposite, you now say plus or minus. Now, looking in the sketch we have here, to the left of the origin, all values of x are negative. So our adjacent is going to be negative 5. It can't be positive this side, so it is negative 5. That is our adjacent. Now we answer the question. We want cos b. We shall say cos b. You go back to the concept I gave you of so, ka, toa. You go to ka. It's going to be adjacent out of hypotenuse. Our adjacent is negative 5. Our hypotenuse is 13. You go to tan b. Tan b, you use toa. Because I said so, ka, toa. So which is opposite out of adjacent. My opposite is negative 12. My adjacent is negative 5. But a negative divided by a negative, you get a positive. It is 12 out of 5. That is tan B. That is when you consider the third quadrant. That is when you consider the third quadrant. We've answered our question. The ratio for cos B is negative 5 out of 13. The ratio for tan B is 12 out of 5. But a while ago, I told you that it can either lie in the third quadrant or the fourth quadrant. So I've given you that scenario when it lies in the third quadrant. We are now going to look at the fourth quadrant. Why? Because signs can be negative in the third quadrant. Signs can also be negative in the last quadrant. Let's look at the last quadrant. What if you sketch it in the fourth quadrant? What happens? If I sketch it in the fourth quadrant, my sketch will be like this. Still the 90 is on the x-axis. This is your 0, this is your 90, this is 180, 270, and 360. Now, the whole of this is the angle. Because you are looking at an angle that lies between, the whole of this is the angle of interest. We are looking at an angle that is lying between 270 and 360. Again, this one serves as my opposite, which is going to be, again, it is below the x-axis, is going to be negative 12. The hypotenuse is 13. You do the same because you want to get the adjacent. So we shall say opposite squared plus adjacent squared is hypotenuse squared. The opposite is negative 12 squared. The adjacent is what I'm looking for. This one is 13 squared. When you square 112, you get 144. That's the adjacent squared, which is 169. Now, when a positive crosses the equal signs, becomes a negative. You get your adjacent squared as 25. The adjacent squared is 25. You take the root this side, you take the root that side. Our adjacent becomes plus or minus 5. Still you say plus or minus when you are either working for the hypotenuse or, when you're working for the adjacent or the opposite, you say plus or minus. We now come here. Now, this side is to the right of the origin, so it cannot be negative. Today it is going to be 5. I chose this number such that you can see when do we use negative 5 and when do we use positive 5. So today our adjacent is positive 5. Let me get the ratios. The first one was cos of B. Again, you go and use your car, which is adjacent out of hypotenuse. Our adjacent is positive 5. Our hypotenuse is 13. And that is the answer. Lastly, we look for tan B. Here we apply TOA. We are going to say TOA, which is opposite out of the adjacent, which is, our opposite is negative 12, our adjacent is 5. These are the 3 examples I prepared for you, and they are very, very useful. Take time, go through. I remain your teacher, Red Duncan from Namugongo Secondary and Vocational School. Please don't forget to subscribe, and you can also continue viewing us to be better people. Thank you so much for watching.